All right. So we're gonna finish off chapter 1 actually today. Don't worry, it's not nearly as bad as it sounds. We're gonna look at section 1.2, 1.3, and 1.4, which basically all are wrapped up around random sampling and how you choose the people that you're going to survey to get the actual good data. So statistics in general, all the formulas and everything else work as long as you have a random sample. If you don't have a random sample, your information is going to be skewed or biased and stuff like that. So you want to make sure you get that random sample ahead of time before you start doing anything. We're going to look at a few different ways that you can get that random sample today. So the first one is literally just a simple random sample. So use a number generator or a random number generator to pick a certain group of people that you're going to talk to. So you could have student IDs all listed there and have a computer randomly select, say, 30 of them. And those are the people you're going to talk to. You don't know who they are. There's no connection to it. It's just looking at the student IDs and like, okay, this is the person I'm going to go talk to. And actually, that's how a lot of things end up working, is they'll throw everybody into a program and then just randomly send out surveys to certain people. What's some of the downsides to that? If I randomly just selected people based on their ID numbers, would that be, do you think that always give me a good representation of the school? What? Okay. But we can't, so here's the problem is like, you would definitely want to survey everybody if you could. So in a school like Three Rivers, I think there's 2,500 students that go here, 2,500, 3,000 students. You could reasonably survey everybody by sending something to email if you know that everybody's going to answer their emails. Or you can randomly survey if, like, yeah, all the teachers hit everybody. But even then, you're probably not going to hit everybody. You're going to miss some people who weren't there or whatever. But what if I wanted to do a survey of the entire United States? We're talking 350 million people. I don't think you get a quarter of them. Like, I think honestly, the last election, or the election in 2020, was probably the most well voted in election that we've had, and you still only got about half the people. So actually, it was a little less than half the people. So you're never going to get that many people, and kind of think about the cost. All right, somebody's got to actually look at the survey, actually talk to the person, or send them the link, make sure they can fill it out and stuff like that, and validate the information. Like, every person that you do, that costs money. And when you're talking about millions of people, that's a lot of money. That's why the census is only done every 10 years. Because that is literally talking to every single person in the United States. And it costs billions of dollars to do. Okay? So a random politician or organization isn't going to be able to do that. So they need some way to be able to sample that information. And simple random sampling is the beginning one. That's the basic one that people do. So if we look at a small group, so they have the top 5 Oklahoma State officials. They have the governor, the lieutenant governor, the secretary of state, the attorney general, and the treasurer. They want to obtain a random sample of 2 officials. So the first thing we have to do is actually list out all the possible combinations of 2 officials. Think about rolling dice. You have 2 dice, 1 through 6. You roll them. You want to list all the combinations of those 2 dice. When you're doing so we're going to talk about probability too in this class. When you're doing anything like that, you want to do it in a systematic way so you don't forget things. Don't just randomly pick 2 numbers and then try to write out all the things. You're going to miss one. It's inevitable. So start off with the first order. So in this case, we're going to do G. And then write every one after. So GL, GS, GA, and GT. So we've taken care of all the G's now. Now we move over to the next letter. So if we're talking about dice, we'd start off with the ones, do all the ones. Then we move over to the twos. Now, do I have to do LG? No, because that's the same as GL, right? So I can start off with LS, LA, and LT. Now I'm done with all the L's. Now we do the S's. So now I do SA and ST. Done with all the S's. Now I can start with the A's, AT. And now I know I have every possible way that you can list them. Right? When you're trying to list them out, do it in a systematic way. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 options. And say I want to pick 3 of them.
I have a quick question.
Yeah.
Why didn't you say LG as another selection?
Because so G is governor and L is lieutenant governor, right?
Yeah, but why didn't you also write LG? I mean?
Right. So does it matter which order I talk to them in? They're the same people, right?
Right.
So I wouldn't have to list them twice.
Because only a member has to be listed once. Can be selected at most once.
Right.
Since the question was asking that we should be listing the possible samples of 2 officials from the population of 5
Without replacement.
Without replacement.
Right.
Yes.
So that's why you don't have governor.
That's why we wrote only GL, but not GL and LG.
Right, because LG would be the same combination of those 2 people. So think about it like if you're rolling dice, you're going to have replacement, right? Because you're going to have 1-1 or 1-2. If you're picking playing cards, you're probably not going to have replacement because you're going to pick the cards up. So you have a queen of spades. You're not going to be able to pull another queen of spades out of the deck of cards. Depending on what you're doing, if you're rolling dice, rolling a 1 first and a 2 the second die might not make a difference if you roll a 2 and then a 1. There's still a sum of 3. It might not make a difference. Some cases it might. In this case, LG and GL are the exact same thing, so I don't have to list it twice. And that's actually important to understand because sometimes does make a difference in the order, sometimes it doesn't. So I've got 10, what was it, 10 people? Yeah, right? Okay. How do you want to randomly sample 10 people? Could work. That would work. Roll a d10 3 times. Yeah. That'd be a random sample. Yeah. Yep, you can use a random number generator. Same kind of concept as rolling a d10. Okay.
Wait, what's rolling a d10?
Believe it or not, dice are all not 6-sided. Most dice is 6-sided dice. But
I've never heard of a 10-sided die.
Yeah,
I've heard of 6-sided die, but I've never heard of a 10-sided.
There's a 4-sided die. There's an 8-sided die. There's a 6-sided die. There's a 10-sided die. A 12, a 20, and a 100.
Have you seen the 2-sided die? It's kind of like pill shaped, but it's pointed at the end, so it can kind of only land on one of the 2 sides. It's like a fancier coin.
I was gonna say at that point I just flip a coin. Yeah, I just flip a coin
But
at that
it
point.
looks cool.
That's cool. The 100-sided die are really weird because it's like you actually have like literally 100 sides, which are really hard to actually get to stay. So it's actually a little magnifying glass. It tells you where it is. Yes, there's many-sided dice, normally used in role-playing games. But it's the same kind of concept as a random number generator. So, what would you not want to do? So here's the thing. We are horrible random people. We all have patterns. Okay? If I asked you to write out 100 single digits on a piece of paper, you will have your favorite number more than like most. Okay? It's just, we can't do it. So you do not want to be the person trying to randomly sample without using something to do it for you. And that's where the random number generators come in, or a die or a coin, things like that, because those are typically random in nature. All right? Okay. Yeah. I'm not going to do the 4-1. It's not really needed. All right. So let's look at this one. So one of the things that I asked you is, what's some of the problems with random sampling? And there's three main issues. The first one is undercovered. So sometimes an accurate and complete list of population is unavailable. So if I was going to do a survey of the entire city of Norwich, for example, okay, I wanted to get a survey of them, and I want to randomly select people from Norwich to ask questions to. What populations would be underrepresented or undercovered in that situation? What people might be harder to get a hold of? Military, yeah. Members, they might not be around as much. What else?
Police officers?
Well, not necessarily. I guess at that point, if we're going in that direction, people who work full time and have like our odd schedules and stuff might be harder to get a hold of. But yeah, homeless would be very hard to get a hold of. That's actually one of the hardest problems with censuses is trying to get numbers of the homeless. Yeah.
Low income families?
Lower income families can be very well underrepresented in a lot of these surveys. Immigrants can be well underrepresented because they're fearful of the authority in answering questions. So they might not be as forthcoming. So if you don't have a very good start point, your data can be biased in some directions or other directions. Okay. Non-responsive. We talked about this one on Tuesday. Is that some people just don't answer questions. All right. We said, how many of you guys actually answer the phone and talk to a pollster? It's like most of you, like what do you, most of you do not. All right. So your non-responsive rate, especially for younger people, are typically higher. So your response rate is going to typically skew older and more affluent in nature. So they have a tendency to be overrepresented, and the younger generation tends to be more underrepresented. So how can we change that? How can we change that? How can we actually change it so that we can get more representation from the younger people? Because I don't think, in general, you guys are going to start answering the phone and start answering and talking to pollsters. So how could they represent you guys? Yeah, I'll ask you and then us.
Wait, do you want to answer first or her?
No, you can answer first.
Oh, okay. So I was thinking we could run a social media account with like a poll on it and have let people of our age range answer the questions on their phones without having to actually talk to anyone.
Okay. Would that give you a random sampling?
Probably not.
Probably not. So that starts running into the problem, right? What was your suggestion?
I was gonna say, like, email the poll out.
Okay.
A lot of people don't like talking to other people. They don't have to talk to someone. That's the number one way you're gonna get them to answer things.
Okay. Would that be able to get us a random sampling?
I'd say not exactly right. Because only people that actually care about it are gonna answer, which then skews.
Right, but that goes back to our non-responsive, right? That's gonna hit that part. But would that lower the non-response rate for that population? Okay. Is there a way to make it so that we could use social media and kind of what you did with email to get a higher rate, but still have that randomness of like, because you're not going to email everybody. You'd only email the random people that, like the people that hit, that were randomly selected would get emailed. Could we do that through social media though? Is there a way to contact people randomly on social media? ads and commercials and stuff like that, but that falls into the same problem as he had, that you're only going to get people that actually see that. Now, yes, I know it typically gets filtered, but you can send DMs, you can send private messages, stuff like that, through surveys and stuff like that are randomly selected. There's ways to do that. Unfortunately, a lot of social media and companies and stuff like that have restricted that stuff to prevent things like that from happening, because unfortunately there's people out there who use it for bad purposes too. And that's some of the things that unfortunately you guys in your generation have to start figuring out. It's like, how do you get this information? Right? You have a lot of people who are very socially active that get their voices heard, but the vast majority of people don't. Vast majority of people would literally just like, leave it alone. That I'm just going to do what I want to do. I don't really care. It's like, but the longer you go on, the more you're going to realize that this stuff actually can come back and does make a difference. So we have to figure out some ways to be able to start engaging them. The next one is actually really important in how you ask questions. Response bias. So why would a survey question, do you smoke marijuana, result in response bias? Yeah.
Some people may not want to answer the question.
Yep. Anything else? Or was everybody going to say basically the same thing as that? That goes back to the concept I said the other day with Trump, right? People didn't want to actually say they were voting for Trump, but they weren't. So how could you change that question so that you can eliminate the response bias? That's important.
Have you been under the influence of THC? I don't know.
Okay. I think people probably still would lie at that way. Yeah. Most polls actually are anonymous. The problem is you're talking to somebody, people don't like that. So if you have it on a survey that's not like paper or like just answering questions online, things like that, some people might answer a little more truthfully because they think they're a little more anonymous. But even if you talk to somebody on the phone, you're anonymous. They have no clue who you are. Most pollsters actually, all it is talk about random number generators. The computer randomly generates a phone number and calls it. And that phone call, then if it goes through, they ask the questions. If it doesn't, they don't. So it's completely random. They don't have your phone number. It's the computer randomly putting 9 digits together. So how you ask the questions can really change the answers you get. Maybe, do you think marijuana should be legal? Instead of asking, do you smoke it? Because I think what they're trying to figure out is like, do you smoke marijuana? It's like, if you smoke it already, you're probably going to want it to be legal. So if you ask the question, do you want it to be legal? Maybe people will be more likely to answer that question, yes or no. Because now it doesn't specifically involve them. It's their feelings on the situation. So when you ask questions, you need to ask them in a way to try to eliminate as much bias as possible. So those things are kind of important. But those things also come from that random sampling. It's how do you get good answers and good data? Because the whole concept of garbage in, garbage out, if we get good information in, we're going to get good information out. If we get a bunch of crap in, we're going to get a bunch of crap out. We're going to make wrong assumptions about things that we need to look at. And as crazy as it sounds, that was section 1 too. So I told you, it wasn't going to be nearly as bad. All right. So let's look at a couple ways. So we talked about just doing random numbers and things like that. That's one way to do it. There's a few other ways that we can do it. The next one that we're going to look at is called systematic random sampling. So the one way that why we're going to look at it this way is we divide the population by the sample size. So this is the process of doing So if I have 1,000 people and I want a sample size of 50, I'm going to split the population up into groups of 20. And then you use a random number table to generate a number between 1 and whatever it is. So if I said to 20, I said 1 to 50. So I got groups, I'm going to do 1 to 50. And then we select a member of each of those. So if it's the 35th, I'm going to pick the 35th person in every population. Okay. What's the one thing that did nowhere in this process did it say? Doesn't matter order of the people, of the population. Did it say put the population in order first? No, because that doesn't matter. Okay, and that's important because, like, I think, as crazy as it sounds, we're talking about we can't be random. We also really like order. Like, if I gave you a list, the first thing probably some of you would do is put it in alphabetical order. If I gave you a list of numbers, you're gonna put it in numerical order. It's just the way we like order. So the concept of this not having to be in order is important because that can affect things. Even if we look at student IDs are not randomized when they're assigned. They're assigned in order. So your oldest people, the people that have been at the school longest or have the lowest ID number. So if you put them in order, you're now grouping people. Where if they're completely randomized, you're not doing that. So if we're looking at this situation, so he has 728 students enrolled in college algebra, and he wants a sample of 15. So he wants 15 students to ask questions to. So how would we go about doing it with this process? Yep. So it's 728 divided by 15. 48 and a half. And we're rounding it down to the nearest whole number. So that means we're rounding this down to 48. Okay. So now we're picking a number from what? One, two. So we pick a random number from 1 to 48. So say 18. So we're going to pick the 18th person from each of those groups. And that should give me 15 people. So, yeah.
Will that still work if 48 points? We just round down for no reason because you can't have a half.
You can't have a half person, so you always round. Right. So if you round it up, you might not have 15 groups. Right. So your groups are going to be bigger, but you might not end up getting that 15th group. If we round down, you're guaranteed to have 15 groups. We might have a 16th, depending on which number you choose. So we might have, like, if you had 18, there might be an extra 18th person there. So we might have 16 people, but having an extra person is not a horrible thing. You don't want less than what you want. So now, is this better or worse than just totally random? It's a little better.
I think it's better for people who value putting things in a certain order.
Well, we're still not doing them in order. It's just here's all my ID numbers. But it allows us to, instead of just looking at a large scale of randomness, we now can bring it down to a simpler thing that a person can do. Like, you're not gonna, like in this case, it's we were looking for 1 to 48. So it's like a random number from 1 to 48 is easier than picking 15 random numbers from 1 to 10,000 or 1 to 728. It's like, and the other thing about it is when you pick them that way, you're not going to get clusters of numbers next to each other. That could happen. So it gives you a little bit more randomness, a little bit more coverage. What do you think would be the next stage of this? Before I go on to the next slide. If we're now taking the people, like, so this case is really actually now taking 728 groups of students, right? And putting them in groups of 48 students. So we've now, what's that called? There's a word for that. We put a group of people together or groups together. Huh? Well, we are making samples. We're also making clusters. We're clustering people. Okay. So the other thing we can do is called cluster sampling. In this one, we're dividing the population into clusters or groups. And then we're obtaining a simple random sample of the clusters, not the people. And we use all the members of those clusters. So, for example, right now in the school, we have, let's say, 40 classes going on. So I have 40 rooms of students. I have 40 groups of students. I have 40 clusters. If I wanted to do a random sample of them, I could pick, say, 5 classrooms and ask everybody in those 5 classrooms the questions. As long as, so right now, the rooms are kind of clustered or kind of randomized because nobody in here knows, like, it's like you chose it because of the class, but it's a pretty random sample. If I went through and then picked randomly the classrooms, would that give me a random sample of the school? At least at this point. Yeah. Would it give me a good random sample of the entire student population? Why? Okay, but I'm never going to do the whole population. Think about, we're talking about this school. So think about this school. Yeah. Okay, we're missing the people that are online. Yeah. Is there a different population of students that take night classes than day classes? Yeah. I'll tell you right now, my night classes are typically an older population. So your day classes are a lot of students that are just out of high school, stuff like that, who might not have full-time jobs during the day. It's like, so you definitely do have a different population at night, so you might not get a good representation in school. And that's when you're looking at any kind of cluster or any kind of randomness, you want to make sure that the sample that you're looking at is indicative of the entire population that you're looking at. Okay, so cluster sampling will work, but you got to make sure that the clusters are designed around the entire population. So an example of that, 300 members of the population are divided into equal sizes of 20. We're going to use the clustering sample to identify 60 from the population. So how many clusters would I need to pick? I need to pick 3. So I have to pick 3 out of 15 of them, right? There'd be 15 clusters. I have to pick 3 of them. And as long as those clusters are relatively randomized, we're good. So all these methods that we're looking at, yeah.
How would you group a cluster without making sure you don't accidentally organize? Just just another random number generator?
Normally when you're doing clusters, and this is actually what we're going to talk about right now, actually, clusters are typically designed around something you already have in place. You just want them relatively equal in size. So, depending on how you want to look at it, they don't necessarily have to be exactly equal in size. This has to be close. And that's actually exactly what this example is going to go into. So, save time, the planner decided to use cluster sampling. A residential portion of the city was divided into 947 blocks, each containing 20 homes. So now, obviously, when they make a math problem, they're going to make it exactly clean as possible. But in the real world, not every block is going to have exactly 20 homes. Okay? So they're looking at the 947 blocks in their town. And they want to pick a sample of 300 homes. So how many blocks are they going to look at in this problem? 15. So they're going to randomly pick 15 blocks and ask everybody in those blocks. Okay. So you want to pick something that's like when I was doing the clustering, we have classes already designed. So that would be the clusters. You're not going to be able to randomly create clusters because then you run into the same problem that you have of going out to those groups of people. Like you have to go to this person and this person over here and things like that. So when you're looking at cluster sampling, the design of it's to save you time and save you money because everything ends up coming down to money. Somebody's paying you to do this survey and they want the best data for the least amount of money. Okay. So when you're looking at trying to do clustering, you want to pick something that's going to be simple for you to do. So in this case, if I'm picking 15 blocks, if I want to do it all at the same time, I need 15 people. I send one person to each of the 15 blocks. They ask 20 homes in that thing of the survey, and we're done. And one day, probably less than a couple hours, they can ask all 20 people on that block the information. I have all my data that I need. All right. Now, what's the problem with that? Because with everything we have, if you're going to save time, you might not like time and money is one thing, but is there a downside to this? Yeah. So you were asking before something very important. You said, how do you make sure that the clusters are randomized? I said, well, you really can't. You have to do something that's there, right? Are blocks of homes randomized? Nope. If we're looking at blocks, so if you're looking at a city or a town and looking at how blocks are grouped, would you get a good sampling of a population if you just chose individual blocks? Why?
Because specifically the home example, like a lot of people that same income are going to live for less. So you're not going to have a billionaire living next to like a low.
Yeah. Okay. Now think about the other part of that. The more money you have, the more spread out your houses are going to be, right? Which might mean that there's less people in that block, considering a more dense population that's typically more low income. So there might be less blocks in your town that have a lower income and more blocks that have a higher income, so they're going to be overrepresented. Okay. Like these are all things that you don't think about when you just read that. When you just read like a poll that you see online, you don't think about all the stuff that goes in behind getting that. And we're going to get, so when we get into chapter 2 and beyond, we're going to start to look at actually calculating and doing those types of things. But it all comes back down to how did you get those numbers? And those numbers are important. That data is important. And if you don't have good data, the conclusions that we make might not be as good as we would want them to be. Okay, and that's where we're looking at this type of stuff. So how could we fix this? How can we fix this and help make it a little bit more representative?
Have like subcategories within the
Okay.
like lower, for example, lower income, medium income, higher income, and then run the sample for each person.
That would work. Knowing the population of the town or the state or whatever else you're doing the survey for is important in that situation, and making sure that you're hitting the representative groups in equal amounts. So if we're looking at, we have a 60% low income, 20% middle income, and 20% high income, I would want my survey results to be 60% low income, 20% middle income, 20% high income. So I might pick more blocks in the lower income section to make sure I hit that 60%. And that's called the next thing: stratified sampling, random sampling with proportional allocation. We divide the population into subpopulations. And we do a very similar thing to what we just did before. Now, you could do this with clustering, you can do this with anything. So stratified random sampling basically means that you're dividing the population into subgroups, and then you're randomly picking from each of those subgroups proportionally based on what you have. Okay? And it doesn't necessarily have to be low, high, middle income. It could be any kind of population. So if we're looking at a population of the entire United States, it's, I think last I looked, it was approximately, I think, 19% Black, about 17% Hispanic, and like breakdown. So when you're looking at doing a survey of the entire United States, you'd want to hit those categories. Same thing with age groups. If we're looking at comparing age groups, you'd want to make sure you hit those categories and those age groups. So when you're looking at surveying people, you want to make sure you hit those benchmarks. Okay. So if we have, so in this example, we have 2,000 members of population are divided into 4 stratas: 400, 600, 800, and 200. I want to obtain a sample size of 10. So how many people from the size of 400 am I going to pick? How many?
20.
Wasn't 20. I only want 10 people. So we have our breakdown, right? I have 2,000 people or 20,000 members, right? Or 2,000 members, sorry, 2,000 members. And I want a sample size of 10. So it's 20,000 or 2,000 divided by 10. Apparently I really want 20,000 right now. 2,000 divided by 10 is what? Yeah, so 200. Now, divide each of those stratas by 200. What's 400 divided by 200? 2. So I want 2 people from that group. What's 600 divided by 200? I want 3 people from that group. 800 divided by 200.
4.
I want 4 people from that group. 200 divided by 200
1.
is 1. So I want 1 person from that group. So I had 2, 3, 4, and then 1. So 2, 3 plus 4 is 9, plus 1 is 10. That's how you choose it. And then we'd randomly select that 1 person or that 2 people or whatever else from those groups, using whatever method we want at that point. Normally at that point, it's a small enough group that you could just use a random number generator to pick the person. Okay. Now, does that take care of some of the inequities that we're seeing in the clustering method? Yeah. Does this method cost more money? I have to go through and I have to organize people and into groups and stuff like that. That's going to cost time, which costs money. You have to relate time to money. If it's going to take the pollster or whoever's doing it more time, it's going to cost you more money. Okay? But will the data be better?
Yeah.
Yeah. Okay? More accurate information. Town swimming pool. If I was going to do this as a cluster sample, I know this is stratified, but there was that actually problem before this one that I didn't put up there. If I was going to cluster it, who do you think in town would be more apt to want a town swimming pool? And who do you think in town would not really want a town swimming pool? Might want it more? Okay. And who would not want it? Huh? Why? They have their own. Okay. So if you're doing clustering, you might get a more higher representation of the upper income and stuff like that that might not want it, or the lower income might want. So we want to look at a stratified version. So the town has 250 homeowners. So right there, did they already put in a bias into this thing with the first statement they made? 250 homeowners. Okay. Because they own homes. Okay. So typically your homeowners are also your property tax people. The people are paying the property taxes. But who do they leave out? They leave out the renters. So if you're renting, they might not ask you, they might ask whoever the landlord is, who may or may not live in the house that they're renting. Okay. So when you're looking at designing things, now in this situation, it might not matter because of the way the town's set up, but these are things you have to think about. And these are things that if you're looking past the actual just like picture that they're giving you with the data on it, these are things you want to read into what they're actually doing. So at the very beginning of every statistical survey is their rationale and their what's it called? How they did it. And there's a word for it, and I can't think of the word off the top of my head. Basically, their procedure, how they actually went through and selected their data and stuff like that. And you want to look at that because how they did it is important. And what questions they asked are important in how they actually got that data. And as we're seeing, that's where those biases and stuff can come into play. So 250 homeowners, we have 25 are upper income, 175 are middle income, and 50 are low income. How do we obtain a sample of 20 homeowners using the stratified approach? So I want 20. So what was the first thing we did in the last problem? I took the total and divided it by how many I wanted, right? So I'm going to do 250 divided by 20. And I'm going to get 12.5. And then I took each group and I divided it by that number, right? So 25 divided by 12.5 is 2. I don't think we had to round this one down. No, because this number right here isn't people. We would have to round this number because that's the actual number of people I want. In this case, that one comes out to be fine. There might be one that comes out. I don't know if 175 does. Actually, it does. Because if you rounded that one, then you're going to get decimals here, which could mess you up. Since that doesn't actually represent people, you don't have to round yet. 175 divided by 12.5 is 2, 8, 14.
Yes.
And then 50 divided by 12.5
4.
is 4. Okay. Do I have 20 people?
Yeah.
Yep. And they're proportionate based on the incomes of this town. Okay. It's like where if I had used a clustering sample of, I wanted clusters of 20 home, or let's see, we'll do 25 homes because it's 250. So I've got 10 clusters in my town, and I'm going to randomly pick 3 or whatever, or 2, or actually in this case, what, you don't really want to pick 1, so we'll pick 2. I might get the entire upper income group, which wouldn't be helpful. So, like, those are the types of things that you want to look at. All right. We're going to quickly go through this. All right. So we've talked about how you pick your samples. Now, when you're picking your samples to do a survey, that's one thing. The other thing that you can do with groups of people is experiments. All right, some can be medical, some can be anything. It doesn't necessarily have to be something that's a medical or those type of things in place. It could be you're looking to figure out this. You can base an experiment on anything, like who uses a toaster oven over an air fryer. It's like things like that. It's like it doesn't necessarily have to be a high-end like drug use cases. Whenever you're setting up the things, we have 2 different groups. We have your experimental units, and then you have your subjects. So your experimental units are the individual items on which the experiment is performed. So that could be anything. It could be mice, it could be refrigerators, it could be anything. If they are people, they're typically called subjects. Right? We wouldn't call a refrigerator a subject, but we call a person a subject. Okay, so but those are basically very simple. So if you hear subject or experimental units, we're talking about the same thing, except if they say subjects, are typically talking about a person in that situation. Whenever you're setting up a experiment, there are a few things that you need to make sure of. The first one is the control. Whenever you're trying to determine if something is working, you need to have a group that doesn't have any change in it. You want to keep all the parameters equal. So that's your control group. A lot of times when they're doing drug experiments and drug trials, they typically give that person a sugar pill. It's a placebo. It looks the exact same. It tastes, everything else is the same, except there's no drugs in it. Why do you think they actually have to give them a pill? I said this very specific word a second ago that has meaning. The placebo effect. There's quite often when you take something, even if it does absolutely nothing, you feel better. Okay? Because you think you're doing something. So they actually have to give them that pill or the injection or whatever else it is so that they can rule out any placebo effect. Okay? Because a certain group of those people that are taking the sugar pill or getting the saline injection or whatever else is going to report that they're doing better, even though they're not. And they need to make sure that the drug is doing better than even that. Okay? So you need to have some kind of a control. You need it to be randomized. So the units should be divided randomly into groups. So you don't have any selection bias. That should not be done this is where the blind and the double blind comes into play. You want people who are outside doing that random selection so that you do not have any influence over it. It's also why they typically, when they take volunteers into groups, they don't tell you which group you're going to be in. Okay? They don't want people promise that they're going to get this drug or whatever else because that would ruin the actual data. And you also should be able to replicate it. So you want to make sure that it's randomized. And you want to make sure that you can detect any differences among it. All right. So you want to make sure that it hits all different types of people or all different types of objects. If we're talking about refrigerators or microwaves or dogs or cats or whatever it happens to be, you want to make sure that it works the same for everybody. That's where your entire list of side effects comes into play. They have to list everything that happened in their group. Even if it happened to one person, they have to list it. Because if it happened to one person in their trial of 500 people, it could happen to 1 million people in the entire world population. And that would make a difference. So that's why those list of side effects are massive in it. You also want to make sure that it can be replicated by somebody else. So when you're listing out your procedures and stuff like that, somebody else has got to be able to replicate that stuff. Told you, chapter 1's a ton of definitions and words. All right, when you're doing an experiment, your response variable is what you're trying to measure or observe. So if we're looking at microwaves and how well they heat, my response variable is going to be the temperature of the items in the microwave after 30 seconds. Okay, that would be the thing that I'm going to measure or observe to determine if the microwave is doing what it's supposed to do. Okay? Or if I'm designing a new microwave, I'm going to test it against the old microwaves. The old microwaves would be my control group. The new microwaves would be the actual group that I'm looking at. Factors. Factors are variables whose effect in the response variables is of interest to the experiment. So if we're looking at the microwaves, it could be this new heating element that I've put in this microwave. If we're looking at a drug or things like that, it could be the new medicine and how it's impacting the disease that I'm trying to cure. The levels would be the possible values of that factor. So depending on how you're looking at it, we could have a high incidence, low incidence. There could be different levels that I'm looking for. And it might not all be one exact, it's like yes or no, a true or false type thing. There could be different levels of it. And the treatments are each experimental condition. So I might do more than one test. So we could have a drug trial that's testing 3 or 4 different drugs that are supposedly doing the exact same thing against a control, so that we can see which one does better than the other ones. So you don't necessarily only have to have one treatment there. Sorry, I went too fast. All right, so let's look at one. So we've got weight gain of the golden torch cactus. Yeah, no, we all work on things differently. People less like cactuses. The researchers examined, they were investigating the optimal method to producing these cacti. So the researchers examined, among other things, the effect of hydrophilic polymers and irrigation regimes on the weight gain. Can anybody pronounce it better than I can? Hydrophilic? Hydrophilic? How is it? That sounds better. Hydrophilic polymers are used as soil additives to keep moisture in the root zone. For this study, the researchers chose broadleaf P4, a polyacrylamide, abbreviated P4. The hydrophilic polymer was either used or not used, and 5 irrigation regimes were employed: none, light, medium, heavy, and very heavy. All right, so What are the experimental units in this situation? Yeah. All right, they're the plants, the cactus. Okay, what's the response variable? What am I looking for? What am I trying to measure?
You're gauging the weight gain.
We're gauging the weight gain. So the response variable is going to be my weight gain. Does that make sense? Okay. What are the factors that I'm looking at?
Hydrophilic polymer and irrigation regime.
So I'm looking at how the hydrophilic polymer is working and the irrigation regime. Okay, so those are the two factors that I'm looking at. So we'll keep going, then I'll do the next piece. What are the levels of each factor?
Non-light, medium, heavy, and light heavy.
Okay. So I had two factors, right? So is what you gave me the levels of the irrigation regime or the hydrophilic polymer? The irrigation. So none, light, heavy, or medium, heavy, and very heavy is the irrigation. So those are the factors or the levels of that factor. But we also have the levels of the hydrophilic polymer.
So these are fine.
Right. So that's with or without, on or off type thing. Okay. So we have 2 for one and we have 5 for the other one. What are the different? So how many treatments do I have?
You would have 10 treatments for this.
I would have 10 different treatments, right? So this is no different than like we were setting up the governors and those things, right? So I would have 10 separate treatments here. I would have, so no the P4, no water, light water, medium water, heavy water, and very heavy. And then with the P4, with the polymer. So which group is my control group? Yeah.
No water, no P4.
Well, it would definitely be the no P4, but there might be water in the situation. So in essence, really, this one's going to be my control group, the no P4. And that's going to be, because I'm really trying, what am I really trying to test? I'm trying to test if the P4 is helping improve the weight gain, right? So I'm really not trying to test if the water is helping the weight gain, because the water is just water. I'm really trying to help test if the P4 is helping the weight gain. So this just here is just giving a variety of different irrigation methods that would happen out in the real world. This is my control group, and this is my test situation. But I got to look at each one individually because heavy water might have an impact on cactuses who don't really want a lot of water. So that might have a major impact. So if I just looked at this as one group and then compared it with heavy water down here, this one I'm really comparing to that one, because I have to compare it to an equal watering gauge on the other side. And maybe the P4 wants more water than the thing. So you don't know. Those are the types of things we need to look at. All right. Let me go back to that randomization. We can have different ways that we're randomizing those samples of people. Okay. A completely randomized design is just like my random number generator. That's that sample at the beginning where everybody's just thrown into a pot and I'm picking half of them to get this one and half of them to get the other one. Or in that situation, I have 10 different tests I'm going to do. So I split the groups up randomly into 10 different groups. What's the randomized block design similar to? That we've already talked about. So I'd get my blocks and then I'd pick the clusters to set it up. Notice what it doesn't say here, though. It doesn't say it has to be randomized clusters, right? So you could do the stratified here too, where you're picking out, okay, I want this group and this group. So all right, last problem. And now you know why having this in one 2.5 hour class is kind of long. Suppose we want to compare driving distances for 5 different brands of golf ball for 40 golfers. So if I'm looking at this right now, what's my experimental units?
40.
The golf ball brands. Okay. Not the golfers. I'm not testing the golfers. I'm testing the golf balls. The golfers are just kind of like the water for the cactus plants. It's just those are the ones that I'm using to test it. But I'm really testing the driving distance of those golf balls.
It makes more sense. In golf for each golf ball.
Yeah. So each golfer is going to have to hit all 5 balls. But do you want only one golfer to do it? So think about this as an experiment. I'm testing the golf balls, not the golfers. So I have 5 different brands of golf balls. How many times do you want to run that experiment?
40.
They're running it 40 times with 40 different golfers. Okay. So they're going to hit, each golfer is going to hit the ball 5 times with the different golf balls. Now, if I actually remember the example in the book, it actually doesn't do it this way. They actually give the golf balls to different golfers and actually have them hit it and then average them out. But is that going to be a better representation of if, like you said, have the golfers hit all the golf balls? Because what would make a difference in the golf? Like if I had one golfer just use their one brand of golf ball. If I just had the golfer use the one that they liked and they randomly select the 5 golf balls and they just use that one. What are some things that could come into play? You'd be biased.
The golfer.
Strength of the golfer, male, female. They're drastically different in the driving distances. So that's where the completely randomized design and the random block design comes in with this situation. Where they were randomizing design, they would just randomly pick a golf ball. The block design was they had to split up into males and females. So this way they could see the differences in there. But the method that you said when you had the golfer hit all 5 golf balls actually makes a lot more sense in this situation. Yeah.
What about acuity? Like
How
each
good they are?
how good they are, yeah.
Yeah.
Their sharpness.
Yeah, that would make a big difference too. So there's lots of things you could literally. So a randomized block design, you could do male, female. You could do pro, intermediate, amateur levels. And that's the thing. It's like when you're looking at a block design for your experiment, you can split it up into a lot of different ways. It doesn't necessarily have to be. It has to work for whatever your experiment is in that situation. All right, and we're done. And now your brains are fried. we go through chapter 1 because there's just, it's a lot of vocabulary type of things. Chapter 2 and stuff like that starts getting more calculations and numbers and stuff, which is going to make a lot more sense. Except we're going to use a lot of these terms, so understanding what this is important. Okay. I would look at, so if you go to the book, the examples at the end, I wouldn't try necessarily doing all the exercises in every section. What I would do,
Wait, did you say all the exercises in every section?
yes, I would not try to do all the exercises in every section. Okay, because there's a ton of sections. And when you start to look at doing them in specific sections, like if you want more practice on doing the stratified thing, go to section 1.4, do those, because that's where that is. Or 1.3. Sorry, 1.4 is the experiments. That would make sense. But if you want to really make sure that you understand like everything in the terms, do the section at the end of the chapter. We finished chapter 1. So I would look at the review problems and then the applying problems at the end in chapter 1. Oh, yeah, I'm sharing. Sorry, yeah. So you've got the review problems and the applying concepts and skills, because they're going to be mixed. So because these are the problems that are looking at the entire thing from the entire section. So it's not necessarily going to be just one thing that you're going to hit on, which is kind of nice. All right. I wouldn't do them all. The odd numbers you have in the back of the book, so focus on the odd answers. I don't have the answers to the even ones for this book. They didn't give me an answer book, so I literally have exactly what you have. But that doesn't mean if you send me an even problem, I can't help you figure out how to do it if you want that. So like if there's an even problem, it's like, oh, this one looks really interesting. Like let me focus on that one because it hits. There's a bunch of different types of problems in here that hits different interest areas. You can look at those things and have no problem. If you need help, I'm here all day. But you also can send me an email. As he found out, I respond pretty quickly. As long as I'm not physically doing something, I get back to you pretty quick. So because it goes right to my phone. So even if I'm sitting there watching TV, I can respond back to you. So if you have a question, email me and I'll get back to you and answer it. Don't wait till Tuesday if you have a question on your homework. I will be here early on Tuesday. I'll be here. I'm normally here by 9 o'clock. So if you want to come in a little early, if you have other questions, we can answer them there too. Okay. Have a good weekend.